So we're going to be doing lesson number 2 today, something called complex numbers. Can y'all see that? Should I try zooming it a little? Oh, that might be better there. Okay. Is that better? Oh, complex numbers. Okay. Well, the last time we reviewed square roots, we didn't review it, we had a whole assignment over square roots, and we listed out perfect squares, the numbers whose square roots we knew, like, well, 1 times 1, that's a perfect square, but I won't bother writing that. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. It goes on and on. 11 times 11, 12 times 12, ... These are numbers whose square roots we know just from the multiplication tables, and they're not decimal. They're perfect squares. Oops, I should have said perfect squares. Now, I'm going to put a big X right here because this is a common mistake, but I'm about to write us wrong. Sometimes students will see things like the square root of negative 25, and they'll write negative 5. But that's wrong. The square root of negative 25 is not negative 5. Why? Well, negative 5 times negative 5 is positive 25. In general, the square root of a negative number is defined to be an imaginary number. So, this is something I'm not assuming you've seen before. The square root of a negative. We're defining the square roots of negative numbers as imaginary numbers. And we're going to denote an imaginary number with that lowercase letter I. So while this statement right here is wrong, let me write it out correctly now. If we have the square root of negative 25, let's see. Did everyone sign on the roll sheet? If your name isn't on there, you need to tell me, okay? Your name wasn't on there? Well, let's see. Oh, pardon me? Oh, but I printed this out this morning. And so, during the break, speak to me, okay? I might have to send you down to the registrar, or over to the registrar's office, okay? Which is actually, you can just take those stairs that are closest here, down one level, and then take the walkway over to the Harvin Center, and you're already on the 2nd floor. So that actually works good.
I actually took that walkway on Monday.
Uh-huh.
The door on your side is
it's locked. Well, on Monday morning I got here, and in order to get to the 2nd floor, if you're going to take stairs, you got to go out and take the outside stairs. I climbed the outside stairs, and the doors were locked. I had to go back down the stairs and around to the the room that has the elevator. So speak to me during the break, okay? So the square root of negative 25. Well, we're saying the square root of a negative is an imaginary number. So the way you do this, you just do the square root of 25, that's a 5, and then stick an I on it, because you're saying the square root of a negative. I'm not sure if you can tell these colors. That's a blue I, and the reason you have the blue I there is because of the blue minus sign. And it's sort of hard to tell. I should have used a red. Maybe I'll start using a red there. Okay? Let's look at problem number 1 in this assignment. Oh, let's see. Here it is. Problem 1. Look this up. Oh, you know what? Let me just do it like that. Square root of negative 81. Well, yes, 9i. Someone's already got. So this is problem 1. The square root of negative 81. Well, the square root of 81 is 9. The square root of a negative is an imaginary. So we have this red I here because, I knew that was going to happen. I was going to forget to toggle back. Okay? We have this red I here because of the red minus. Okay? So you just, to simplify a square root, an imaginary number, you simplify the square root of the positive in the normal way, and then just stick an I on it. So I'll come over here and punch in 9I. They have this little I key right here if you want to use that for some problems. Sometimes it's not there. And so just use the I on the keyboard. Okay? As a general rule of thumb, when working with this Pearson MyLab, never enter a capital letter and don't hit a space key. You'll notice it spaced it correctly. If you're typing it in correctly, it will space it correctly. Okay? If you do this, 9, and then put a capital I, this sure looks like a 91, doesn't it? Notice, did it space it? No. Lowercase I. If you start hitting space keys or capital letters, it messes up the little programming for how the formatting. Okay? So let's do problem number 2 now. The square root of negative 108. Let me write it down. The square root of negative 108. Well, when you look at your square root of negative 108, when you look at your perfect squares, 108 is pretty big, but it's not one of the perfect squares, is it? Okay? So the question is, can we simplify? Is there a perfect square that divides evenly into this? I downloaded my virtual calculator the other day. So if I just started going through here, I'm using this calculator to demonstrate my thought process. Is 108 divisible by 4? Well, yeah. Well, what about bigger? Is there a bigger perfect square that divides into 108? Okay, I heard 36, and that's right. 108 divided by 36 is a 3. So we can come over here and rewrite the 108 as 36 times 3. And let's go ahead and put an I on it already because of this red negative right here. The red minus under the square root. We're going to have a red I there. The colors really aren't significant, okay? They're just trying to show you, why do I have that I? Because of the negative there. Now, one of these square roots we can simplify. That square root of 36, I could go ahead and write just as a 6. And the square root of 3 we can't simplify. Where you put the I doesn't really matter, except it's sort of standard when you have a number and a square root, to put it in between. 6i square root of 3. Pearson doesn't care where you put that I in as long as you don't do this. Right there, what I've just written, it looks like the I is under the square root symbol. The I should not be under the square root symbol. Okay? So, pull up the problem and type in, what did he say, 6i. Notice you have to click in the box before it shows these tools down here. Square root of 3. Okay. Any questions there? So we've defined imaginary numbers as square roots of negatives, and in the process we've defined real numbers. Throughout your mathematical algebra career, teachers have talked about real numbers, without ever actually saying what exactly they mean by real number. Now we can define it. A real number is any number that is not what? Imaginary. There it is. Anything like the square root of 75, that's a real number. Only the square root of negative 75, that's not a real number. The only thing that are not real numbers are the square roots of negative numbers. Now, think back to an earlier algebra class. You would have remembered your teacher talking about combining like terms. If you had something like 5x plus 7x, you could combine those and write them as 12x. Why? Well, they're like terms. They both have the same variable. But if you had something like 5x plus 7, suppose there wasn't an x here, could you combine those together? No. Okay? They're not like terms. Well, suppose we have a real number and an imaginary number at the same thing. Suppose we had this. The real number 7 plus the imaginary number 8i. Could I combine this 7 and this 8 together? No, they're not like terms. There's not an I on the 7. When you have an imaginary number together with one of these real numbers, where one has an I on it and one doesn't, that's called a complex number. And you can't actually add the 7 and 8. You can't get a 15. So, complex number is in the form A plus BI. With a complex number, you have a real number and an imaginary number. But you can't actually add the two numbers, the 7 and 8, because they're not like terms. You just got to leave it like that. Problem number, don't panic when you see this next one. Problem number 3 is going to look pretty scary at first glance. It says, write this number, it's a messy looking fraction, in standard form. Type your answer in the form A plus BI. So we're going to write it as a complex number. So let me write this problem down. Okay, this problem. This problem 3. Negative 2 plus the square root 8 all over 2. Negative 2 plus the square root of negative 8 all over 2. Problems 3, 4, and 5 are the same type of problems. And I'm going to do 3 and 5. I think 5's the one that's a little bit messier with bigger numbers. Now, to get started, we're going to simplify the square root. So I'm going to simplify the square root of negative 8. Now, negative 8 is not a perfect square. So to simplify the square root, the first thing I'm going to do is ask myself, is there going to be an I here? Yes, because of this red negative under the square root, there'll be a red I. I'm just going to go ahead and stick it right there. Okay. Now, square root of 8. What perfect square divides evenly into 8? Yeah, 4 times 2. That's not too difficult. 4 times 2. So, if you can tell the colors on here, and I'm not sure if they're showing really well, this blue square root of 4, I'm just going to write as a blue 2. Okay, and then we write the I, and then the green square root of 2. Now the colors at this point aren't really that significant. So I've simplified the square root as 2I square root of 2. Now I'm going to rewrite the top, replacing the square root of negative 8 with 2I square root of 2. So we have a negative 2 plus 2I square root of 2. And then notice it's all over 2. Here's the tricky part. Both of these terms are over 2. You've got to put both of these over that 2 and the over 2 over 2. Both of these terms are over 2. And now cancel. Sometimes students will only cancel one of these 2's right here. But in actuality, they're both being canceled. Negative 2 over 2, how would I write that first fraction? Would that just be a negative 1? Then this black plus I'm about to write is this one right here, plus, what am I about to write here? Okay, cancel the 2's, and we have I square root of 2. So negative 1 plus I square root of 2. And that's what I'll type in. And when I type that in, I won't hit space keys, and I won't hit a capital letter. Okay? So, coming over here, pulling this up. I'm going to notice there's no little tabs for me to click on yet, until I actually click in this box. Then it shows all this stuff here. I type in negative 1 plus, notice it doesn't show the letter I down here. Okay? You can click more and it'll eventually show it, but just hit that letter I from the keyboard. Square root of 2. Okay. Any questions there? 3, 4, 5 are all exactly the same, so let me do 5. 5 usually has a little bit bigger numbers, and it looks like it does. So let me write it down. Negative 8 plus the square root of negative 20 all over 24. So, oh, well, why'd I put that in? Oh, you don't see that. Good. Now, if I ever just start working out long problems over here and I haven't switched the screen, y'all call out. Okay? It's going to take me a while to get accustomed to this. Okay. I'll start off simplifying the square root of negative 20. Well, I'm going to go ahead and write the I right now so I don't forget it. I'll just stick an I right here. What perfect square divides evenly into 20? 4 times 5. So if I think of this as 4 times 5. The square root of 4. I'll put a 2. Then I'll write the I. And the square root of 5. Now let me rewrite it, replacing that square root with 2i square root of 5. Some of y'all sitting in the back, there's no, if you want to just spin your chair around and use the other table, that's right there, that's fine, okay? So, let's see, rewriting it. Negative 8 plus 2i square root of 5. It's all over 24, but you need to actually write it putting each one of these over 24. Okay? You separate it out. I didn't show this step right here. I went straight to separated up here on this one. So let me see. If I separate it, negative 8 over 24 plus 2i square root of 5 over 24. This one's going to be sort of messy to type in, I think. Simplifying the negative 8 over 24. Can I reduce that fraction? Yeah. Negative 1 over 3. 8 goes into 24 3 times, so we have a negative 1 over 3. This black plus I'm writing here is that one there. Now let's cancel the 2 and the 24. 2 goes into 24 12 times. So it would be I square root of 5 all over 12. There's actually a lot of different ways you could type this in correctly in my math lab. I always put the term that has the I second, because A plus BI is the definition of a complex number. But if you wanted to write the I term first, like up here on number 3, you could type in I square root of 2 minus 1, and it'll take it on my math lab. Okay? So there's a lot of ways. You could write this fraction minus a third. My math lab will take it. In fact, if you wanted to put the I way out to the side, it'll take it. I think probably this is the easiest way to type it in. And let me show you how to do that now. Right here. So it's negative 1 over 3, negative 1 slash 3. Be careful. I can't hit the plus right there. Because that plus is in the bottom of the fraction. It shouldn't be there. So either move your mouse and click outside of the fraction, or I'm just going to hit the right arrow. Okay? Then a plus. Now this next fraction is so messy, I'm going to actually click this key here to enter it in. And what is it? An I. Notice it doesn't have an I there, but that's okay. There's an I on the keyboard. Square root of 5. And in the bottom, 12. Any questions on that? Okay. Are y'all caught up with me? So, now we're going to start adding, subtracting, multiplying, and dividing fractions, complex numbers. Well, let me write this one down. We're starting to add, subtract, multiply, divide complex numbers. And pretty much it's just based on rules of algebra. 5 plus 7i plus 2 minus 6i So what we're doing now is adding two complex numbers. That's what those parentheses are indicating. Here's one complex number, 5 plus 7i. Notice you can't write that as 12. And then here's another one, 2 minus 6i. So what we're doing is adding complex numbers. In order to add complex numbers, you just combine the like terms. Like I can't add the 5 and the 7, but what could I combine this 5 with? Yeah, 5 plus 2 is 7. Now, what can I combine this 7i with? Yeah, 7i plus a negative 6i, 7 minus 6. That would just be a 1. So I'll just write plus I. If you want to write plus 1i or type it in, it'll take it. So 7 plus I. So if you wanted to write a rule, how do you add complex numbers? Well, you just combine like terms. Now what did I say the answer was? 7 plus I. Notice how it's spacing it nicely. So to add complex numbers, you combine like terms. To subtract, it's just like when subtracting any other algebra expression. There's going to be an extra step here. What do we have to do when there's a minus sign in front of the parentheses?
Convert everything into parentheses into the opposite sign.
Okay. The phrase I'm going to say is distribute the minus, which is going to change all the signs inside the parentheses. But this is number 7. Let me write it out first. 1 minus 4i. And then I'm going to put the minus in a different color. Minus 4 plus 5i. Minus a negative 7 plus I. Ooh. This is an I. It sort of looks messy. So I'm now subtracting complex numbers. So what I'm going to have to do is distribute this minus through each set of parentheses there. The first set of parentheses, I don't need it at all. So I'm just going to drop that first set of parentheses and just write 1 minus 4i. Now distributing that pink minus, I'd have a minus 4 and a minus 5i. And then over here, I'd have a plus, distributing this minus, that would make it a plus 7 and a minus I. So now, let's see, what can we combine here? Well, let's see, what can I combine with the 1? The stuff I can combine together, I'm just putting a little green mark under them. May not be able, it looks black, doesn't it? Well, okay, I'm putting these little marks. What can I combine? The 1, and plus 7. So 1 minus 4 plus 7. Well, 1 plus a negative 4 is negative 3, plus 7 is positive 4. Now let's combine the I terms, keeping in mind that this the I right here, where there's not a number in front of it, there's still a 1 there in front of it. So we have negative 4 plus a negative 5 plus a negative 1. Minus 10 I. Negative 4 plus a negative 5 is negative 9 plus a negative 1 is negative 10. So we have 4 minus 10I. Don't get carried away and get a 6 or a negative 6 out of that. The 4 minus 10, you can't subtract those. They're not like terms. So 4 minus 6. No, I didn't. 4 minus 10I. Any questions? To add or subtract complex numbers, that's not really a difficult thing. To add them, you just combine the like terms. To subtract, you got to distribute the minus before you combine the like terms. Now I want to review something that, a rule that we stated the last time. I don't know if y'all remember this rule. We had a rule about square roots times themselves. Here was a rule from the last time. The square root of A times the square root of A equals just A. I want to go ahead and rewrite that rule in a different way.
We can't see that.
Oh, we can't see that. Oh, there, sorry. Square root of A. There. Square root of A times the square root of A is A. That was a rule we stated on Monday. And you can convince yourself real easily if you just put some small numbers on. Square root of 5 times the square root of 5 is the square root of 25, which is just a 5. There's another way this rule could be written. Instead of saying times itself, we could say squared. Doesn't squared mean times itself? So if I just rewrite this rule with a square, we still have the same thing. The square root of A, all squared, is A. With it written like this, what it makes you think is a square and a square root cancel each other out. Okay? But it's still just based on this rule right here that we used the last time. Now I'm going to try to develop a rule that we're going to be using for problems 8 through 15. Okay? That's what I'm doing now. In a minute I'll circle a rule. If we went back to, what was problem number 1? Was it square root of negative 81? Okay? Square root of negative 81 is 9i. What if we'd had this one? Could y'all simplify this? The square root of negative 1. Well, how would y'all simplify square root of negative 1? It's just I. Y'all hear that? The square root of 1 is 1. The square root of a negative is I. So if someone wanted you to define what is the definition of that little letter I, there it is, the square root of negative 1. Now, I'm going to take that statement and reverse it. Write it like this. I equals square root of negative 1. And then I'm going to put a square on each side. If I square both sides, then we're going to get a rule that I'm going to put a black star by. I squared equals, looking at this right-hand side, remember the rule about a square root and a square canceling each other out. What am I about to write right here? -1. The square root and the square. So here's a rule that you're going to need to know to do problems 8 through 15. I think it pops up on just about every one of those. Be careful. I'm not saying I equals -1. I'm saying I squared. Sometimes once students see that, they start going back and they want to go like to problem number, what was that last one we did, 7, and start putting a -1. No, no, no. Only if you have an I squared will you put -1. We've added complex numbers, we've divided complex numbers. Now we are going to multiply. When there's no symbol in between the parentheses in algebra, we always assume that's multiplication. So let me write this problem down. And as I'm writing it down, I want y'all to think about how you would have done this in a previous algebra class. In algebra, there's 2 F words. One of them is a 4-letter F word. FOIL is what we would do on this one. Now remember FOIL, first, outer, inner, last. And so, all of you are different students. By that I mean some of you have done this algebra recently. Some of you, it may have been a long time since you've done any algebra. The person sitting beside you took algebra last semester, then they'll remember stuff easier than someone that's been 5 or 10 years. What does that mean? Well, if you don't remember it, you just got to work a little harder than someone that had algebra real recently, okay? So sometimes students say, oh, I'm going to drop the class and take it. No, 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 just work harder, okay? Based on my 29, well, it's been over 30 years, but I've been here at Delmont for over 29 and a half years. It's not about the algebra classes you've taken in the past. It's about how hard you're working right now. Okay? So, I'm about to start foiling. That's the first, outer, inner, last. This is when you're multiplying. Doing the first. -2 times -3 is a +6. First. Outer, -2 times a +4, -8, I. Inner, 6i times -3, is that going to be a -18i? I'm foiling this the same way I would if it had just been an x. Okay? Don't let the fact that there's an I there worry you. Still do it the same way. Now I've done first, outer, inner, now the last. 6i times 4i, that's a +24. I times I, I'm not just going to write an I here. What am I going to write? I squared. When you multiply I times I, that's when you get the I squared, and that's the first time the I squares popped up. It pops up when you multiply. Now, if this had just been a plain old algebra problem with x's and stuff, you'd combine the -8i and the -18i and be finished. But wait a minute. With imaginary numbers, whenever you have an I squared, you should replace it with -1. So I'm about to replace this I squared with a -1, which is going to do what to this 24 here? Positive 24 times a negative 1 is a negative 24. Now, if this were PowerPoint, these numbers here would just float down. But they're not. So I'm just recopying the black, green, and blue number. And now I'm ready to combine the like terms.
Negative 18 minus 26.
Okay, the 6 minus 24. Those are like terms. 6 minus 24 is a negative 18, so I agree with that. Now what about the i's? Negative 8 plus a negative 18, what's that going to be? Negative 26i. Don't get carried away and put a negative 1 there where the I is. No, no, no. Only I squares get replaced with negative 1. So we have negative 18 minus 26i, which I will come over here and type in. Negative 18 minus 26i. Check it. Let's do problem number 9. Nine minus 5i squared. Y'all caught up? Are there any questions? Well, I claim that number 9 is exactly like number 8, except there's one extra little step at the beginning. The most basic form of problem solving is when confronted with a new problem, try to make it look like one you know how to do. We know how to do it if there's two sets of parentheses like this. You FOIL it out, replace the I squared with negative 1, combine like terms. Well, here there's not two sets of parentheses. What am I trying to say we need to do first here?
9 squared minus 5i squared.
Okay, you write this. You write it twice. You don't just square the 9 and square the 5i. You write it with the two sets of parentheses. Isn't that what squared means, times itself? So once you have it written with the two sets of parentheses, do what we did on the other problem, number 8. Let's see. 9 times 9, I'm FOILing out now. We'd have 81. Is this going to be a minus 45i? Oh, I feel sort of stupid. I keep looking this way when I'm looking to see if it's showing. But I could just look right over there. It's right in front of me. Oh, wow. Okay. Okay. Are we ready for enter? Is that going to be another minus 45i? And first outer enter, and the last is going to be a positive 25 I squared. But wait a minute. What am I going to have to do with that I squared? It's going to be a negative 1. Are y'all caught up? Any questions? The I squared is a negative 1. So this green plus 25 is really just a minus 25. So I'm replacing all of this plus 25I squared with the minus 25. All the I squared does is change the sign of the number in front there. So I'm going to pretend that's not there. And I'm not going to bother recopying that. I'm just going to combine the like terms. What can I combine with the 81? Okay, so 81 minus 25. Is that going to be a 56? Yeah, I agree with that. Now be careful. Negative 45 plus a negative 45. Negative 90. Sometimes students want to cancel those out. No, it's a negative. If it had been a negative 45 and a plus 45, negative 45 minus 45 is a negative 90. So 56 minus 90I. Here. And, oh wait, click there. Was it 56 minus 90I? Hey, the little I key symbol is here. Not always, so just use the I on the keyboard. Any questions there? So to multiply, you're foiling and replace the I square with negative 1. What about number 12 here? Three plus 4I times 3 minus 4I. There's this weird little teacher option on some of these where the order can be scrambled. I wonder what the logic for that would be. Why would I want to not let you know that this one's like number 12 on your assignment? So 3 plus 4I times 3 minus 4I. Well, FOIL, replace your I squared with negative 1. Let's see. Let's start distributing. We'd have 3 times 3. Oh, I'm going to start foiling. Distribute the 3. So, not first. Outer, a minus 12I. Inner, what's the inner going to be? A plus 12I. And then a minus 16I squared. Good. Now, replace the I squared with negative 1. So that's going to make it just a positive 16. So all of this is just going to be a plus 16. Maybe you just want to put the plus here and mark out the I squared. I'm just going to write plus 16 right there and mark out all of that. Now let's combine. Oh, something's going to happen here. What's our answer going to be?
25.
Just a 25. There's the I's here. Yeah, unlike this one up here, where they were both negative 45. Those didn't subtract down. But here a negative and a positive 12 sure do. So just 25. You don't have to type in an I. Yes. 25. Now, a little terminology. Okay. If you have two complex numbers and they differ only by the middle sign, a plus bi and a minus bi are called conjugates. Only the middle sign differs. Oh. Oh, my writing is horrible. Conjugates. Reminded of my best friend back in the 90s. Taking a algebra class at Lee College, and I asked her, well, how on the first day, how do you like your teacher? And she was like, oh, he is an idiot. And I thought, oh gosh, okay, let's end this conversation. And I was, oh, I'm sorry to hear that. She said, you won't believe what he does. He spells the words out to us. And I was, oh, well, actually, I sometimes do that. I did it just a while ago, Conjugates. And ever since then, I've tried to stop that. But whenever I'm writing something, and my writing looks particularly messy, and it might be a word you've never used before, I sometimes spell it out. Because that C-O-N-J, my U, I can't tell what the heck that is. So, conjugates. Now, what's special about these conjugates? Well, have we seen any conjugates so far? Well, yes. The last problem I just did, the 3 plus 4i and the 3 minus 4i, those are conjugates of each other. What's special about conjugates is if you multiply them out, do you have an I in the answer? Number 12, was there an I in the answer? No. That's the nice thing about conjugates. If you multiply conjugates together, the I terms, the outer and inner, cancel out. Well, let me show you for a moment what I'm about to write might make more sense if you see what the next problem is going to look like. When we talk about dividing complex numbers, we don't mean long division and stuff. They're written as fractions. So keep in mind, that's what the problem's going to look like, but I'm going to write out how to do this before. This is the one type of problem that sort of needs a little explanation before we actually do it. So, to divide complex numbers, here's what you're going to do. Multiply above and below by the conjugate of the denominator. Multiply above and below by the conjugate of the denominator. So let's look back at that problem and let me write it down. And then we'll, let's see, 3 plus, this is problem number, which one? 13. 3 plus 5i divided by 1 plus I. Dividing complex numbers. This is the one thing, it'd take a while to figure this out on your own. How the heck, or what are they doing to do this division? You multiply above and below by the conjugate of the denominator. So if someone says, say something that'll impress them in algebra, what could you say? To divide complex numbers, multiply above and below by the conjugate of the denominator. What the heck does that mean? Okay. I'm going to multiply this problem, or this fraction, by what? The conjugate of the denominator. The denominator is the stuff in the bottom, right? So what's the conjugate of 1 plus I? 1 minus I. With a conjugate, you just change the middle sign. Okay? So I'm multiplying above and below by 1 minus I. So we're going to have to FOIL twice. So I'm multiplying by conjugate of 1 plus I is 1 minus I. Just change that middle sign. Now let me start. I think I'll come down here and do it. FOILing the top first. We'd have a 3. Then a minus 3i. A plus 5i. And is that going to be a minus 5i squared? So I FOILed the top. Now I'm going to go ahead and FOIL the bottom. We'd have a 1. Then a minus 1i, or just a minus I. And then a plus I. I've done first, outer, inner. I'm about to do the last. I times negative I. Would that be a negative I squared? Now, replace both of those I squares with what? Negative 1. Okay? So I replace those I squares with negative 1. This green minus 5 is just going to be a plus 5. What about this one here? In the bottom, if I replace those the I squared with a negative 1, we have a blue negative, negative 1. Will that be a plus 1 there? So I'm all of this stuff right here I'm replacing with this plus 5. This minus I squared I'm just putting as a plus 1. Now let's see. What do we have on top?
8 plus 2.
Okay, the 3 plus 5 is 8. The negative 3i plus 5i, that is a plus 2i. And now on the bottom, what's happening? Are there going to be any i's? No, look, you see the i's subtract out. What number do we have on the bottom? Yeah, 1 plus 1, a 2. And we're still not finished. Don't get carried away. Sometimes students will just cancel the 2 pink 2's and say 8 plus I. No. If there's just one number in the bottom, you have to separate it the way we did here on number 5. So, here's the little universal marks for separate. 8 over 2 would be just a 4. The 2 over 2, those cancel. 4 plus I. So 3 plus 5i divided by 1 plus I is 4 plus I. Highly unlikely you would just guess that. Not a lot of applications of these complex numbers. In fact, after the first few class periods, we'll spend the rest of the semester saying, oh, we're not interested in imaginary, just real numbers. But, well, there's not, at this level, no applications. any future electrical engineer, vast applications in magnetic field theory. Okay? So are we going to be seeing any word problem applications of these imaginary numbers? No. This is way beyond the scope of the course. If you look at those student learning outcomes that I stated on the syllabus, which I don't like to look at on the first day, you'll see something about operations on complex numbers. No applications. Just add, subtract, multiply, divide, complex numbers and imaginary numbers. Okay? Let's do one more of them before I break. Let's do number 15. It's the last problem in the assignment, so it must be the hardest. Let me write this one down. 9 divided by 1 minus 3i. So we have the real number 9 divided by the complex number 1 minus 3i. Well, multiply above and below by the conjugate of the denominator. So what's the conjugate of the denominator? By conjugate, that means change the middle sign. In general, that's what any conjugate means. Change the middle sign. So what am I multiplying above and below by? 1 plus 3i. So on top, we don't really have to FOIL. You just distribute the 9. So that's easy. We just have a 9 plus, is that a 27i? And now we FOIL out the bottom. Okay. First, 1 times 1. Then a plus 3i. And is that going to be a minus 3i? And what's the last one? Negative 9i squared. Which, if I think of I squared as negative 1, all that's doing is changing this negative 9 to a plus 9. Okay? So if you just want to mark that out and put a plus, that's fine. I squared is negative 1. Now, on the top, we can't add the 9 and 27. There's not a lot we can do on this, except right here in the bottom, what am I about to do to the 3 i's? Yeah. And once I've done that, I can also add the 1 plus 9 to get 10. So we have 9 plus 27i all over 10. Now, if we, like up here on number 13, when I separated, we could cancel. If I separate this, can I actually cancel anything? 9 over 10, 27 over 10. So I can leave it like that. Separating it, you can't cancel anything. Unlike up here, the 8 plus 2i all over 2. You could cancel it. Okay? So 9 plus 27i all over 10. So I'll say fraction 9 plus 27i. Oh, wait, what's going on here? I think I've zoomed too much. 9 plus 27i all over 10. Any questions there? Okay.
When it comes to
Mhm. It's only if there's something you can cancel. If you want, there's no. This answer would be right if you'd separated it 9/10, and it would take it. You could type that in, and that would be a perfectly legitimate answer. But since you couldn't cancel anything, you don't have to separate it. Here on this one, yeah, you can cancel. Okay. That's why you had to separate it. Okay? And so I think it's probably easier to type this one in, just one fraction, versus this one. That's why I'm typing it in like that. Okay? Okay, good question. Another question? Well, we'll take our break now. In 10 or 15 minutes, we will